Today's lesson is 8.2 Reflections Day 1. Line reflections are flips. The line where a mirror could be placed is called the line of reflection or the line of symmetry. This link that you see here, we're going to watch this in class and I'll give you another handout to go along with that. A reflection can be thought of as a flipping of an object over the line of reflection. Each segment is reflected in segment AB. Draw and label each image. So to reflect P over this dashed line AB, it's like folding the paper in half right there. So P would swing down here below AB at a point equally distant away from that line of reflection. 3 units up is P, so 3 units down would be P's image, or P prime. Q would do the same thing, only it would flip above AB, folding the paper in half. This would go up to approximately Q prime, or Q's image above that. Go 3 units above. E, so now my line of reflection, folding the paper in half like hot dog style, E would go 2 units to the right, would be E's image, and F would also go 2 units to the right, F's image, F prime. The image and its reflection are congruent. They're the same shape and size. That's what congruent means, the same shape and size. The line that runs between them is equidistant to the line of reflection. So the line that runs between them is equidistant to the line of reflection. So 2 units away, 2 units away, 2 units away, 2 units away. Again, the line of reflection was this original AB. Peter folds a piece of rectangular paper into half. He uses a pencil to poke a small hole through the folded paper. He then unfolds the paper and labels the 2 resulting small holes A and A prime. If the distance between A and the fold line is 2.5 centimeters, then find A all the way over to A prime. Well, the distance between A and A prime is actually 2.5 times 2. This is the times symbol here, times 2, which would be 5 centimeters away, because the fold line, if they're 2.5 apart, then this would also be 2.5, right? So 2.5 times 2 gives you 5. The distance between A and A prime then is 5 centimeters. Number 1, the reflection in the x-axis. The original coordinates, so A, we're going to call A is -2, 1, as you can see there. B, on the coordinate axis there, is 3, 1. And C is 3, 4. We're going to reflect it over the x-axis. So here's my line of symmetry, the x-axis here. So A has to come equally distant. It has to become perpendicular and equally distant away from the line of reflection. So A's image would now become -2, -1. And B's image, equally distant and perpendicular to the line of reflection, would be 3, -1. C's image would become 3, -4. And yes, please use a ruler or a straight edge to connect your triangle A prime, B prime, C prime. So what do you notice about the original image and its coordinates? The x values remained the same, right? The x coordinates, or the x values, coordinates, are the same. The y coordinates, however, 1, -1, 1, -1, 4, -4. The y coordinates are inverses, or another word for that is opposites. They become their opposite, their inverse, their opposites. So x remains x, and y is its inverse, -y, or the opposite of y, or the inverse of y. So when you reflect over the x-axis, the y coordinates become their opposites. Reflection in the y-axis. So we've got a quadrilateral here, P, Q, R, S, and P is 2, 2, Q is 4, 3, R is 5, -4, S is 1, -3. And we're going to reflect it over the y-axis. So now the y-axis is our line of symmetry here, folding the paper hot dog style kind of idea. So reflecting over the y-axis, P becomes 2 to the left, so P's image. Q, which is currently 4 to the right, comes over here and becomes 4 to the left, equally distant and perpendicular. S is 1 away from the y, the line of reflection, the y-axis. S's image becomes 1 unit away. And R, which is 5 units away, swings over here 5 units away on the same y value, but the x value is now its opposite. Ooh, that's R. That's R, the image of R. So again, let's use our ruler or straight edge. I'm going to use my line tool. P, Q, R, S, and then connect back up to P there. So our P prime, the image of P, went to -2, 2. And Q prime went to -4, 3. And R prime became -5, -4. And S prime became -1, -3. So our x coordinate, 2, -2, 4, -4, 5, -5, 1, -1. So when we're going over the y-axis, our x coordinates are inverses or opposites. And our y coordinates remain the same. So our rule, x becomes the inverse of x, and y remains the same. So all of our x values became their opposite, our y's remained the same. That's the rule for reflection in the y-axis. Going back, reflection in the x-axis, going over the x-axis, our y coordinates are the inverse or opposites. Number 3, Number 4, the vertices of a triangular traffic sign are 0, 4, -4, 0, and 3, 0. Reflect this figure about the X. I'm going to let you do number 4 on your own. Put on those points, U, V, and W. Connect it, make the triangle, reflect it over the X-axis, right? And we'll talk about number 4 in class.